This whole doing the same thing over and over again until you're really good at it, it's studying.
Is that how you record your thing? Can they hear me right now?
Hey, what's up, anybody that watches the video?
It's there.
Alright.
Oh yeah, what is your YouTube channel, man? How many subscribers you got?
I'm going to be giving you the answers to the Mercury station. This is what it should look like. Your atomic number, number 1, most everybody knows that one. E was 8. If I know the atomic number, what two subatomic particles do I know as well? Protons and electrons. So how many protons do I have? 80. How many electrons do I have? 80. That's the 8 in 8-man. A equals P equals E. Atomic number equals protons equals electrons. All the same numbers. You don't do any math at all for that part. What was the atomic mass for Mercury? You round it up to the nearest whole number or down to the nearest whole number, depending on which way it is.
Really? Would we have got it wrong if we didn't round it up?
Yes. You would have figured it out if you had a multiple choice answer and the only one you had was close to what you had, you'd probably be like, okay, it must be that one. But writing it out, you would have got it wrong. Alright, what period is it in?
6.
6. You start at hydrogen and you count down. Hydrogen is 1, 2, 3, 4, 5, 6. The 6th row is where it's at. What group number is it?
12.
12. You didn't even have to count that. Look at the top of your periodic table. It tells you. That column is 12. You don't even have to do any counting or thinking about that. Alright, we already answered 5 and 6. The only thing you gotta do math-wise is figure out the number of neutrons.
120.
It is the atomic mass, which is 201, minus the atomic number, which is 80. You should have 121 neutrons.
Yay. Mine.
The last question tripped you guys up, and it's all about memorizing the location of things on the periodic table based on those colors. Whenever you guys colored in the periodic table, you colored in what were metals, what were non-metals, what were metalloids. You're not going to be able to give that exact chart on your test. However, you will have this. Remember that staircase, that bold staircase right there? Indicates the division between metals and non-metals. Anything on the left side of that staircase is a metal, anything on the right is a non-metal, and the stuff that hangs out on the stairs is in between. It's called a metalloid. So is this a metal, non-metal, or metalloid? It is a metal. It is pretty much the only metal that is liquid at room temperature. Alright. Before we start diving back into notes, I'm going to show you a quick music video. You got a question or you struggling?
I have a question.
Go ahead.
So, for mercury not to be in liquid form, does it just got to say poop?
No, as long as it's at room temperature, it's a liquid. You have to freeze it pretty cold to be able to get it turned solid.
To keep it solid.
To keep it solid, you got to keep it cold, yeah. Otherwise, if you lay it out on the counter or whatever, it's going to turn right back to liquid. All the metals really don't do that. They're all pretty much solid. So the periodic table was developed or founded by a dude named Dmitry Mendeleev. And this dude, hundreds of years ago, before microscopes, before protons, neutrons, atomic numbers, he took these elements and said, some of these things have stuff in common. I'm going to group them together. And there is where we came up with our families in our periodic table. Later on, we realized, oh, these things that have similar properties, this is how many electrons they have, this is how many electron shells they have, this is how many protons they have. And now we have it by similarities and left to right in numerical order. Now, back in Dimitri's day, he only had a handful of elements to work with. But over the years, we have discovered lots more elements. We're discovering new ones every year. And as of 2018, these are all of the elements of the periodic table.
Make this equation true. You can also insert.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen, helium, and lithium, beryllium, boron, carbon everywhere, nitrogen all through the air, oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, no gas is stable, halogens and alkali react aggressively. Each period will see new outer shells, will electrons are added, moving to the right. Iron is the 26th, and cobalt, nickel coins again, copper, zinc, and gallium, germanium, and arsenic, selenium, and rhodium, purple krypton, half-side of the rubidium, and strontium, and yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
and cadmium, and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, and boron, rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead that is good for your tummy, polonium, acetine would not be yummy, radon, and cesium will last a little time, radium, then actinize at 89. This is the periodic table, no gas is stable, halogens and alkali react aggressively. Each period will see new outer shells, will electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, titanium, fermium, and delirium, nobelium, lawrencium, rutherfordium, rubidium, supercium, borium, caesium, neptunium, neodymium, morphinium, copernicium, neodymium, flerovium, moscovium, livermorium, tennessine, and organesson, and then we're done.
Thank you guys so much for if you like the song, make sure you check it out on my YouTube for the link.
There,
Is it not on? Because it's on here. It's 2009.
their other videos are pretty funny. They have a lab rules video that is a new rules parody. It's pretty funny.
Please don't.
I am not putting it on. I am not putting it on. Okay. So there's something I need you to update in your older, I won't say older, we just went over it not too long ago, older notes before we move on to the new notes. On page 16, 17, there's one word I want you to add. And this is because I know I have said this word, but I did not make you write it down, so I don't feel comfortable with you not writing it down. It's Halogens, halogen. So on your periodic table, halogens all you need to know about halogens is that it's the name for group 17. I do not want you to get on a test and see that word and freak out because you don't know what it means. All it means is it's an element that comes from group 17. not time for you to discuss anything. On your test, if it says, what is the most reactive non-metal group on the periodic table? It may not have a number down there. It may have noble gases, alkaline earth metals, transition metals, and halogens. And you know, when they're talking about halogens, they're talking about that number 17, so that's what you should pick as the answer. I also put it on my legend under the non-metals. It is a non-metal. Halogens are non-metals. They're just being a little bit more specific when we say they're halogen non-metals. After you have that written down, turn to page 20, and let's talk about chemical reactions, which is the fun part of chemistry. Next week, I've got some chemical reaction labs planned, but we gotta get the information down before we can start just mixing stuff. You know? So doing the Cornell style notes again. Our question on the left, our notes on the right. This is a lot like the setup we have for physical changes in properties. Ryan, get your notebook out before this. What is a chemical property? This is kind of a redundant definition. It literally means the ability of a substance to undergo chemical changes. It seems kind of like a good kind of definition, but that's what it is. But here's the key. That second bullet point right there, the chemical identity of the substance is changed. So unlike physical properties, if we want to measure a chemical property, that changes what the substance is altogether. You have brand new substance with brand new properties. If I wanted to observe the melting point of something, I could heat it up, melt it, and then turn it back to solid over and over again. And I can make observations about that physical property. However, with chemical properties, after I observe it, I can't go back. I can make my observation, but it's now a new substance, and it is irreversible, which means it cannot go back, cannot be changed back. That's why I circle and starred and made irreversible pretty noticeable, because that is a big difference between physical and chemical properties. Physical properties are reversible, chemical properties are permanent. Can't go back. Next topic on the left-hand side is examples of chemical changes, and I added in /properties because you cannot make a observation about chemical properties without causing a chemical change, so they're kind of one and the same. First example is toxicity, and that's just how toxic something is. And if it's toxic, that means it's bad for you. labeled toxic, don't eat it. Probably shouldn't even touch it. It's just, Tide Pods are toxic, seriously, don't eat them. I mean, it's sad that we actually have to like say that, but there you go. So if I have a substance, and really the only way we know it's toxic is because somebody has either touched it or ate it and has gotten sick or died. And we're like, huh, so he ate that and then he died. We probably need to check that out. Oh yeah, look, it caused a chemical reaction in his blood and it killed him.
What if something else happened besides him eating that?
Kind of violent.
Like, what if he ate it, nothing happened to him a month later? He ain't got a disease.
Probably not the reason why he died. Has anybody ever heard of arsenic?
Yes, rat poison.
It is rat poison. Used to be rat poison.
Used to be rat poison.
Not too long ago, they discontinued arsenic in the product known as Decon. Decon is a poison that you put out if you have a rat or mouse infestation. You throw down some Decon, they eat the Decon, they die. Because of the arsenic in it, because arsenic is toxic. However, they recently have banned the use of arsenic in Decon. Does anybody have a guess why?
People ate it.
Because people ate it, mostly kids. Because if you ever see Decon, it kind of looks like green rock candy. It's like green sugar candy. So, you know, and a kid that doesn't know any better, ooh, candy, let's eat it, yeah, I'm dead. So they have banned the use of arsenic because it's highly toxic.
Kind of like that.
Also, if you have, and this has happened actually in the campground that we go to, they had a lot of mice in the campers that were stored there, so they put down Decon, and the mice died. However, there was also stray cats and people's pets that roamed around, and the cats would eat the mice, and then the cats would die. So we had to tell them, like, you can't do that anymore. They have other toxic substances that are less candy looking.
But does it look more dangerous then?
Does it look more dangerous?
Yeah.
It looks just as dangerous, but it's not as dangerous. It's not as toxic to humans.
So it's kind of like that antifreeze stuff.
Does it taste nasty?
Yeah, antifreeze. Supposedly antifreeze is sweet tasting. I've never tasted it, but that's why dogs like it because it's sweet tasting. Cats don't have the taste buds for sweet, so cats usually don't eat it. But dogs are like, it's sweet stuff, and then they get kidney disease. All right, flammability. How easily something catches on fire. Make hands go. How do we know something's flammable? How do we figure that out?
You go like this to it. If you gotta press it or something, you go like that.
It's so stupid.
The only reason we know something is flammable is because we've set it on fire before. So how easily it sets on fire is flammability. Now, once you burn something, it cannot be reversed. It is changed into a whole new substance. It's changed into ash, which is carbon, and it's changed into a gas, usually carbon dioxide. So you can't put it back. It's irreversible. So if something's flammable, you gotta store it properly. So if you're in your high school or college chemistry classes and you see one of the substances has a flammable warning on it, it's gotta go in a special storage place, away from heat. True story. Anytime you have something explode or catch fire, it's always a chemical reaction. Those are the cool chemical reactions. Stuff blowing up and catching on fire.
You wanna do something like that in here?
Unfortunately, no.
The outside.
If you come to one of our science camps off school grounds, I usually try to set something on fire, blow something up at some point in time.
Yeah.
But at the middle school level, we do not have the safety equipment that allows us to be able to use explosive or open flame stuff. That's the way it is. All right, stability and reactivity. These are kind of opposites of each other. They kind of describe the same thing. If something is reactive, That means it is easily reactive with other substances. So that's what two groups on the periodic table that's easily reactive.
Alkaline, one,
One is alkaline and 17, which is, we just learned,
Which color?
halogens. Halogens. Yeah, I can catch up on. So those descriptions, saying those two groups are highly reactive, that is a chemical property. If you're not highly reactive, then you're stable. What group on the periodic table is really, really stable? 18, which is known as
noble gases.
the noble gases or inert gases. Those are stable. All right, next item is called pH. Lowercase p, uppercase h. There is a complicated chemical explanation for what pH is. It involves hydronium ions and hydrogen levels. I'm not going to fill you up with all that because you don't need to know it right now. That's something for higher level chemistries. What you need to know is that pH describes how acidic or alkaline something is. So if you're an acid or a base. Everybody's heard of acids before, right? Or something's acidic. Sulfuric acid is one. Hydrochloric acid is one of your flashcards. Citric acid is in a lot of fruits. A lot of everything. There's a lot of citric acid and stuff. It is a scale that goes from 0 to 14. How many of you are 14 years old? I expect all of you to remember that scale, 0 to 14. Don't have a birthday between now and your test.
14.
Don't say you didn't learn nothing in science class today. You learned these 14. You do need to know, that's what the scale goes to. You need to know that if your pH measures less than 7, then you're an acid. So things like sodas, fruits, stomach acid, battery acid, you're all a pH of less than 7. Yes, sir.
Why are we able to consume acid?
Why we have what?
Why are we able to consume acid?
Because we are consuming low levels of acids and there's lines in our digestive system that protects us against it. If you have a pH greater than 7, then you are an alkaline or base. Things that have a really low pH, so 0, 1, 2, 3, or really high pH, 10, 11, 12, 13, 14, that kind of thing, they can really hurt you if you consume them or get them on your skin. So if anybody's ever handled batteries that have exploded and got that powdery stuff on the outside of it, that's battery acid, and if it gets on your skin, it will burn the crap out of you. Bleach is really alkaline. If you leave pure bleach on your skin too long, it will give you a chemical burn. Hydrochloric acid, very popular acid, but in a very pure form, it will burn the crap out of you. Stomach acid has a really low pH. The only reason it can stay in our bodies is because we have cells that protect the rest of our body from it. But it's great at digesting food. Question, go ahead.
Isn't calcium alkaline? How you say it?
Alkaline, calcium by itself?
Yeah.
I'm not sure if calcium by itself is probably.
Alright, so why would you consume calcium?
Calcium is a lot of base, stuff like milk is a base. The calcium chlorides are bases. Alright, last bit. How much time do we have left? Until I say so. Legit answer. Exactly. I gave you some examples. We base everything, excuse me, base everything measurements wise pretty much off of water, kinda like we do the distilled water is 1. Everything else is different. If you have a pH of exactly 7, then you're considered not an acid, not a base, but neutral. Water is neutral. Lemon juice has a pH of about 2, and bleach has a pH of about 12. We will be doing some exploration on pHs, both using the colors, and you're like, oh, it's blue, so it must be acid. And I'm also gonna look into getting some equipment from Winston-Salem State that measures acidity specifically on a computer. Yes, sir. Because there is mucus and cells inside of our digestive tract that affects these acids. Sulfuric acid is really good, like concentrated sulfuric acid is really good like that. Yeah. All right, a couple of reminders. Do not leave this building